Hello everyone, welcome back to another video. Today I'm going to be talking about the mean absolute deviation, also known as MAD or MAD. So we're going to be finding the MAD of two separate set of numbers. So let's start. Okay, so my first MAD question is pretty simple. We have 4, 5, 6, and 1, as you can see here. Now, the way to find the mean absolute deviation of a set of numbers is to first you want to calculate the mean of those given numbers. So, let's say we have 4, 5, 6, and 1. So, given these set of values, the way we find the mean is we add 4, 5, 6, and 1. So let's add 4 plus 5 plus 6, and then we have the number 1. And the next step in finding the mean is divide that by the number of values that we have, 1, 2, 3, 4. In this case, we are going to divide it by 4. And now that we have those, let's get 4, 5, 6, and 1. 4 plus 5 is 9. And we have 9 plus 6 plus 1. Divided by 4. We know that 9 plus 6 is 15. 15 plus 1 divided by 4. And now we have 16 divided by 4. And we know that 16 divided by 4 is 4. So now that we have the mean of 4, 5, 6, and 1, we can now move on to then the next step in finding the MAD would be to take this mean. We have 4 as our mean of 4, 5, 6, and 1. Its mean is the average of 4, 5, 6, and 1. And we want to subtract 4 from each and every value. So we're going to do 4 minus 4. We are then going to do 5 minus 4, 6 minus 4, and 1 minus 4, of course. So we can just write these values: 0, 1, 2, and 1 minus 4 is -3. Now the next step is to find the absolute value of each and one of these values that we have. Now to find the absolute value, it's basically just the distance between the number and 0. So the absolute value of 0 is obviously 0, since it's literally 0. So we're going to have 0 and 1, 2, and difference in -3 to 0 is obviously 3. So we have our absolute values. Now the last step in finding the MAD, mean absolute deviation, of these numbers, of any given set of numbers, is to find the mean of our final value. So we're going to find the mean of this final value. Now, of course, we're going to follow the steps I listed above. Using these steps, I can do, well, we know that 0 is, it won't change this value. So we have 1 plus 2 plus 3. Even though this is 0, we should always keep in mind that there are 4 numbers in this set. And at the end, I'll tell you what a mistake that some people might make with this. So we know that 1 plus 2 is 3. 3 plus 3 is 6. Now that we have 3 plus 3 is 6. we have 6. Now that we have 6, we need to see our values. Keep in mind we have 0, 1, 2, and 3. That's 4 values. And 0 counts, so we cannot exclude 0 from this list of values. So now what we'll do is we are going to do 6 divided by 4 would be 1 1/2. If we convert that, and 1 1/2 is nothing but 1.5. So that means the MAD of 4, 5, 6, and 1 is equal to 1.5. 1.5. And with that being said, let's move on to the next question. Alright, so our next question says to find the mean absolute deviation of 71815329. A lot of numbers. This is 8 numbers, so we're going to do it like last time and get the correct answer. So we take this, and this is basically saying that we know our steps. So first step, find the mean. Plus 1 plus 8 plus 1 plus 5 plus 3 plus 2 plus 9. So we have all of our values here. And there's 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. That's what we're going to do. So look at this. 7 plus 1 is 9. 9 plus 8 is 17. We have 17. 17 plus 1 is 18. 18 plus 5 is, we take a look at 18 plus 5 is going to give us 23. 23 plus 3, 3 plus 3 is 26. 26 plus 2 is 28. And 28 or not. 26 is 25, 2 is 27, and then 27 plus 9 is going to give us 36. That is an easy way of calculating these large numbers. And 36 divided by 8, we know that is 4.5, and we know that because it's 4 1/2, which can be easily translated into 4.5. Now that we have that set of numbers, we are going to focus on our next step of finding the mean absolute deviation. So our next step focuses on subtracting our mean from each and every one of these values. So we're going to have 7 minus 4.5, 1 minus 4.5, 8 minus 4.5, 1 minus 4.5, 5 minus, what is that here, 5, 4.5, 3 minus 4.5, 2 minus 4.5, and 9. 9 minus 4.5. So these values We can just list them out. 7 minus 4 plus 5 is 2.5. We have 2.5, negative 3.5. We have 3.5. We have 0.5. We have negative 1.5. Negative 2.5. And of course, negative 3.5. So we're going to move on to the next slide. I'm going to do some different slide. So given our set of values that we obtained here, now we have to find out the absolute value of each and every one of these. So we can do that easily. And of course, we're going to switch negatives to positive. So our final answer, not really answer, but set of values will be 2.5 plus 3.5, 3.5, 3.5, and 0.5, 1.5, 2.5, and finally 3.5. Given these set of values, if we add all of them and divide by 8, we add all of these, that would equal 21. We have 21 divided by 1, 2, 3, 4, 5, 6, 7, 8. And 21 divided by 8. You can do that out here. So, and of course we can keep adding zeros. So, cool. 6, 48, that would equal 2. Yeah, so we should be getting this value. 2.625 should be our mean absolute deviation of that set of values. So yeah. So to conclude, the mean absolute deviation is extremely easy to calculate. Hopefully those examples helped you in finding the mean absolute deviation of other questions, and yeah, I'm going to be continuing the statistics series on math. And yeah, that's it for this video. Hope this helped.